Good morning, my dear Aksharians. Today, let us discuss about the exercise 8.3 in the chapter Real Numbers. Before going to exercise 8.3, let us discuss about some interesting things. That is, in the previous class, we discussed about rational numbers and irrational numbers, as well as we more discussed about rational numbers, how the rational numbers are, and how to find out the HCF and LCM by prime factorization and fundamental theorem of arithmetic. Like this, so many interesting concepts we discussed in previous class regarding rational numbers. But now shall we move on to irrational? Okay? Yes. Irrational numbers. What are irrational numbers? See, a number cannot be expressed as P by Q form. Means a number cannot be expressed as a fraction. A number cannot be expressed as a rational number. That is called irrational numbers. See, observe here, my dear children. Irrationals means a number cannot be expressed as P by Q form. Condition number 1, it is not in the form of P by Q. It is not in the form of P by Q. Right. Why, sir? Why it is not in the form of P by Q? Because it doesn't have perfect value. Perfect value means a number is divided by another number. A number is divided by another number. A number, that is P, if you divide P by the number Q, then the obtained quotient should be terminating or non-terminating recurring decimal. See, for example, in the previous class we discussed already, my dear children. For example, A is a number. If you divide this by B, then you obtained quotient Q. Then R should be 0. R should be 0. Means it is terminating. Means the quotient stopped somewhere. If R is non-zero number, it is not 0, then quotient should be repeating after decimal 3 3 3 3 4 4 4 4 4 1 2 1 2 1 2, like this, repeating. The single digit repeats, or 2 digits, 3 digits, 4 digits, or group of digits repeats again and again. Right. If the digits is repeating, that is nothing but recurring, non-terminating and recurring. If remainder is 0, that is terminating. Such numbers are rational, but here it is not in the form of P by Q. Irrational numbers are not in the form of P by Q, because they won't give the exact value. That's why the numbers, irrational numbers, are in the form of root 2, root 3, root 5, root 7, and so on, like this. It is in the form of like this, root. The another name for this is surds, right? S-U-R-D-S, surds. Okay, my dear children? Yes. So, now one question arises in your mind. Sir, how do you say root 2 is an irrational? How do you say root 3 is an irrational? Prove it, sir. Like that, one question arises in your mind. Yes, my dear children, the same questions are there in the exercise 8.3. Exactly. Now come to the questions, right? Yes. In the examination, the questions are like this. Prove that root 2 is an irrational. Root 2 is an irrational. We have to prove this. Root 2 is an irrational. Very simple and very easiest question, and very important, my dear children. Right? Observe and listen carefully. It is a 2 marks question. Okay? Observe here. Yes. Let root 2 is a rational number. We are assuming here, root 2 is a rational number. Rational is nothing but what? It is in the form of P by Q or A by B. Okay? Yes, it means root 2 is equal to P by Q or A by B. Root 2 is equal to P by Q or A by B. You can take A by B also. No problem. Yes. Root 2 is P by Q. P by Q means here P and Q are co-primes. Listen, my dear children, P and Q should be co-primes. Co-primes means what? Co-primes means what? The HCF of P and Q is 1. In the previous class we discussed. Remember that, my dear children. Co-primes means the highest common factor of any two number is 1. Then such numbers are called co-primes. Right? Yes. P and Q are co-primes. We are assuming, my dear children, root 2 is rational. P and Q are co-primes. We are assuming. Yes. Now, squaring on both sides. Squaring on both sides. Right. It will become root 2 whole square, which is equal to P square by Q square. Right. A square and root get cancelled. 2 is equal to P square by Q square. Now exchange this Q square and 2. It will become Q square is equal to P square by 2. P square by 2, what it means? What is the meaning of P square by 2? It means P square means it is a square number. If a square number is divisible by 2, means P, for example, don't get confusion, my dear children. For example, 16, is it square number? Yes. If you divide 16 by 2, 2 ones are 2 eights are, you obtained one whole number, right? Clear? What is the root of the 16? Square root of 16? That is 4. If you divide by 2, this one, 2 ones are 2 twos are, right? It is also gives complete whole number 1. See, 16 is a square number. P square is a square number. Square number is divisible by 2. In the same way, its root. What is the root of P square? Exactly, that is P. P also divisible by 2. Say, my dear children, in the same way, for example, you take 36. Is it square number? Right. Yes, divide by 2. 2 ones are 2 18s are. Right. You get one whole number here. What is the root of 36? Square root of 36? Exactly, 6. 6 also divisible by 2. 2 ones are 2 threes are. You get one whole number. Right. Clear? In the same way, if I take 25, is it square number? Exactly. Can I divide 25 by 2? without any decimal expansion? No sir. 25 is odd number, it is not divisible by 2, and 25 will not comes in the 2 table also, right? So 25 is not divisible by 2, clear? What is the square root of 25? 5. Yes, is it divisible by 2? No, 5 is also not divisible by 2 because 5 is not multiple of 2, right? In the same way, what they are saying here, if a square number is divisible by 2, then its root also divisible by 2, right? Clear? Observe 16 and 4, 36 and 6, 25 and 5 are not divisible, right? Yes, therefore my dear children, p square is divided by 2, divided by 2. In the same way, p is the root of the p square, p is also divided by 2, okay, right? Yes, it means, remember this is very important statement, it means p square is divided by 2 means p square is multiple of 2, or we can say this, 2 is the factor of p square. Can we say like this also? Yes my dear children, here p is divided by 2 means p is also multiple of 2. Observe the examples. In the same way, 2 is the factor of p, right? Exactly? Yes, 2 is the factor of p square and p. Clear? Yes? Okay. Consider it as equation 1. Now move on to next step. See, observe here. P square divided by 2, 2 is the factor of p square and p, means p square and p are multiples of 2. Now observe, let observe here, let p is equal to 2k, k is any constant number, p is, just now we discussed, p is the multiple of 2, means 2 into k, right? Can I write like this? Yes. Now substitute this p value in this equation, right? Or in this equation also, okay, anywhere. Substitute the value of p is equal to 2k in this equation, right? Yes, the equation is q square is equal to p square by 2, okay. Yes, q square is equal to, p means 2k, square is there, therefore whole square divided by 2, right? Yes, q square is equal to, 2 square is 4 and k square remains same, divided by 2. Observe here my dear children, 2 ones are 2 twos are, right? So q square is equal to 2k square. You transfer 2 from RHS to LHS, it becomes q square divided by 2, which is equal to k square, right? Here also my dear children, q square by 2 we obtained q square by 2. Compare like this, say q square divided by 2, it means what? A square number divisible by 2. Here a square number divided by 2. In the same way, what is the root of the q square? That is q, then q also divided by 2. Can I write it? Therefore, q square divided by 2. In the same way, q also divided by 2. If q square divided by 2 and q also divided by 2, then Q is the multiple of Q square, and Q are the multiple of 2. Q square and Q are multiple of 2, or in another sentence, 2 is the factor of Q square and Q. Can I write like this? Same. Okay. Yes. 2 is the factor of Q square and Q. Right? Okay, my dear children. Yes. Now observe here. Consider it as equation 2. From equation 1 and 2, observe the equation 1 and 2 carefully, my dear children. 2 is the factor of P square and P. 2 is the factor of Q square and Q. It means 2 is the factor of P square and Q square both, P and Q both. Then P and Q are having the common factor 2, then they are not co-primes. This is very important, my dear children. Here observe, P and Q are co-primes. We assumed here. Let root 2 is a rational number, assumed. Root 2 is equal to P by Q when P and Q are co-primes, we assumed. But according to the statement 1 and 2, P and Q are having the common factor 2. If the common factor is 2, then they are not co-primes. P and Q are not co-primes. P and Q are not co-primes. Then our assumption is contradictory. What we assumed? Root 2 is irrational. Root 2 is equal to P by Q. Our assumption is wrong. Contradictory means wrong assumption. Right? Our assumption is contradictory. If our assumption is contradictory, then root 2 is not a rational number. Not rational number means root 2 is an irrational, right? Yes, therefore root 2 is an irrational number, right? Hence proved. Right, my dear children? Hence proved. Okay, understood? Yes, observe here once again. What they have given? Prove that root 2 is an irrational. We assumed let root 2 is a rational number. If root 2 is equal to P by Q, then P and Q are co-primes. Co-primes means the HCF of P and Q is 1. Then only they called co-primes. Squaring on both sides. Root 2 whole square is equal to P square by Q square. Square and root get cancelled. 2 is equal to P square by Q square. Transfer these two, Q square and 2 exchange. Therefore, Q square is equal to P square by 2. Therefore, P square is divided by 2 means 2 divides P square. P is divided by 2 means 2 divides P also. Then 2 is the factor of P square and P. This is the statement number 1. Let P is 2k. Why we took like that? Because here we proved P is divided by 2 means P is the multiple of 2. Multiple of 2 means it is 2k. K is constant. You give any number to the k, you will get the multiple of 2 only. Right. Substitute P is equal to 2k in this equation. Q square is equal to P square by 2. Substitute the value of P. So P is 2k whole square. Q square equals 2 square means 4k square by 2. 2 ones are 2 2s are. Q square is equal to 2k square. So transfer 2, it becomes Q square by 2 is equal to k square. So Q square divided by 2. In the same way, Q also divided by 2. It means q square and q are multiples of 2 or 2 is the factor of q square and q. Statement number 2. From statement 1 and 2, p and q are not co-primes because they are having the factor 2, right? Because that's why they are not co-primes. If they are not co-primes, our assumption is wrong. That is contradictory. Right, my dear children? Our assumption is contradictory. Therefore, root 2 is an irrational number. Hence, proved. Clear? Yes. Yes, my dear children. Now come to the next question. Prove that root 3 is an irrational. I think you are happy now because, sir, it is also the same steps and same process. I will prove it, sir, like that you are thinking now. Right? Yes, once again, observe here carefully and recall about root 2, then try to solve root 3. Right? Yes, now observe here, my dear children. Let root 3 is a rational number. Rational number. Right? Yes. If root 3 is a rational number, then which is equal to root 3 equals p by q, where p and q are co-primes. Where p and q are co-primes. Right? Yes. Now here also squaring on both sides. Squaring on both sides. It means root 3 whole square, which is equal to p square by q square. Square and root get cancelled. So 3 is equal to p square by q square. Now exchange the place of q square and 3. So q square is equal to p square by 3. What it means? It means p square, a square number, is divisible by 3. Here in this problem, a square number is divisible by 3. It means its root p is also divisible by 3. Right? Okay. In the previous problem, a square number is divisible by 2, then its root also divisible by 2. Here, a square number is divisible by 3, then its root also divisible by 3. Can I write it? Therefore, p square is divided by 3. Hence, p is also divided by 3. If p square is divided by 3, then p is also divided by 3. Then 3 is, very good my dear children, 3 is factor of p square and p, right? 3 is factor of p square and p. 3 is factor of p square and p. Clear? Yes. Now come to the next step. Consider this as statement 1. And now come here. Yes, p is equal to let p is equal to 3k, because 3 is the factor of p square and p. It means p square and p are multiples of 3. Clear? Multiple of 3, k is the constant, 3 into k, that is multiple, right? Yes, substitute p is equal to 3k in this equation. Observe here, in this equation, that is q square is equal to p square by 3. So q square is equal, substitute the value of p, that is 3k whole square divided by 3. Q square is equal to 3 square means 9k square divided by 3. 3 ones are 3 threes are, that is q square is equal to 3k square. Transfer this 3 from RHS to LHS, that is q square by 3, which is equal to k square. Right? What it means? It means q square is a square number divisible by 3. Right? Therefore, q square is divided by 3. If the square is divided by 3, then its root, that is q, that is also divided by 3. Right? Clear? If q square and q both are divided by the 3, then 3 is the factor of q square and q. Consider it as statement 2. Statement 2. From 1 and 2, from statement 1 and 2, observe here, from 1 and 2, from the statement 1 and 2, p square and q square having 3 as the factor, p and q are also having 3 as the factor. If 3 is the factor of p and q, then p and q are not co-primes. P and q are not co-primes. Not co-primes. If they are not co-primes, then our assumption is contradictory. Our assumption is contradictory, means our assumption is wrong. What we assumed? Root 3 is a rational number, we assumed like this. Root 3 is equal to p by q, we assumed like this. This assumption is wrong. If it is not a rational number, then hence root 3 is an irrational. Root 3 is an irrational, hence proved. Hence proved, my dear children. Okay. Now, my dear children, prove that root 5 is an irrational and prove that root 7 is an irrational. These two are homework for you. Do it yourself. Try to solve. Okay. Yes, it's very easy to solve these two. Prove that root 5 is an irrational and prove that root 7 is an irrational. Okay. Yes, my dear children, do it yourself.